So in today's video, I want to show you how I went about solving exploit 16 weighted voting found here in the Solidity challenges repo. If you haven't already, go ahead, clone the repo, open it up in your editor. Over on the README, they have a breakdown description. I'm not going to read it all. I will focus on the challenge. We need to exploit this contract to prevent voters from casting their votes and locking them out of their funds. And then they give us the command in order to run our exploit. Okay. weightedvoting.sol. They start by importing the math contract from OpenZeppelin. They have a little bit of state here. So they have a couple mappings for balances. So users balances and a user's voting weight. They track the total amount contributed. All the voters will be in an array, whether or not voting is allowed, and the block at which voting will start. They have another mapping here that just lets you know whether or not a particular address has indeed voted. The constructor will set the voting time. So it's just going to be the block number plus whatever they pass. And then they give us three methods. We have contribute weight, which anyone can call. We have to ensure that voting has not been enabled. And then the second guard here is that the value that you pass has to be greater than 0. So your weight's going to be based on the value that you pass. The more value that you pass, the greater the weight you're going to have. All right, so assuming you get past both guards here, they're checking whether or not you're already a voter. If you are not, they're going to add you to the array. They're going to update your balance, and then they're going to update the total amount contributed. They have a method called record weight and refund balances. It simply checks that voting period has started, and then it loops through all the voters. It grabs their address and their amount, and they run this calculation to determine your voting weight. So you can see it's your amount times 100 divided by the total amount contributed. After that, they're going to go and refund you your ETH, because ETH was simply used for the sake of this calculation here. So they'll send you your ETH back. They ensure that the transfer has succeeded. Then they'll update your user balance. And then finally, voting will be set to true. You may have noticed one thing here that kind of jumps out already is that, again, they're updating state after a call. You could, scream reentrancy. You wouldn't be wrong. Although that is not the attack vector here. At least that's not the way I approached it. All right, double down to here, vote. This is the last function. It has two guards. One, it just ensures that voting is true. If it is, it then wants to know that you actually have a voting weight. Your voting weight cannot be 0. If you have passed both these guards, they're simply going to update the fact that you have voted. So to set it to true against your address. All right, so again, looking back at the README, the goal here, prevent voters from casting their votes and locking them out of their funds. So the way I approach this, it all kind of happens in this method here, record weight and refund balances. You can see that they're running a loop where they are going to refund us. So anytime there's an external call, we have to handle it very carefully. You can look at other videos in this playlist and you can see exactly the same type of problem has occurred here. So they're going to make a call, and if they call an EOA, no problem. If they call a contract, it can be a problem, and we'll ensure that it is a problem. So we'll have them call our contract, it'll hit a receive function, and we'll simply revert. So as long as this contract reverts, voting is never allowed, right? So let's go ahead and do that. So in my attack contract here, I just create an instance of the voting contract. I have two methods. The first one is contribute, where I'm going to call the voting contract. I'm going to contribute some weight. I'm going to pass in my value. Now, even here, I won't get my value back, right? Because you got to use as small a value as possible. Now, my receive function, again, when they do try to do the refund, I'm simply going to revert. This will prevent anybody from getting their funds back. All right, so let's see this in test form. Over here on weightedvoting.t.sol, I import my attack contract. They've set it up like so, where they have the contract, the weighted voted contract. They allow vote block number, so it has to be at block number 200 before voting can start. They have two voters, and in their setup, they deal both those voters to ETH. They deploy the contract with that block number. They prank each voter, and they allow them to contribute their weight, so they're contributing both Ether here, so both contributing to Ether. They have a test pre-check They're asserting that the voting block time is correct. So that'll be block number plus 200. And then they have a handful of asserts here. So the balances of the voters on the weighted voting contract are going to be starting at 2 ETH, 2 ETH. Then they go down to both voters are in the array. So they've been registered. The total amount contributed will be the sum of both voters. Is voting allowed at this point? No, it's not. So it's asserting the false. And finally, their weight. They're checking, is their weight equal to 0? And it would be initially, because that calculation hasn't been around, because that method has not been called. Now they're testing for voting weights. Here they go ahead and they roll ahead past the 200 block. They now call record weight and refund balances. Here they're asserting that both weights for both voters are going to be 50. They then further prank each voter and then allow them to vote. Once they've voted, they check it state if their vote status is true, and it would be. And that would be a successful flow. And now our job is to make it unsuccessful. They give us a block here to write our exploit, and I have 2 lines of code. That's all it took, right? I imported my attack contract. I went ahead and deployed it with the address of the weighted voted contract, and then called contribute. And I'm passing in 1 ether. Now, once that's done, they have some code here they're going to run. They're going to roll past 200 block again. So now voting is enabled. They are going to expect a revert. So once this method, record weight and refund balances, is called, they're asserting that the balance of both voter 1 and voter 2 are 0. Now, this is the balance not on the contract, but their personal EOA. This would be after the refund. So after the refund, they should have had a value. But because of the revert, they're expecting both values to be 0. Furthermore, they're going to prank each voter. They're going to expect a revert, and they're going to call vote. And it is going to fail because they don't have a weight, because it was never set, because that transaction reverted. All right, that was a mouthful, I know. Let's go ahead finally and actually see that play out in the terminal. So over here, I've already preloaded the command. We'll run it. So from the top here, we have test prevent voting, where we deploy our attack contract. Our attack contract calls the contribute method on it, which then reaches out to the voting contract and contributes weight of 1 ether. The test rolled ahead past the 200 block. It expected a revert. And when we called record weight and refund balances, you can see the first 2 refunds were successful, but the third one, when they called our receive function, picked it up and then reverted. You can see that right here. All the asserts ended up being true, that both balances of voter 1 and voter 2 on their EOAs were indeed 0. And then they tried to vote and they could not vote because they didn't have any weight. So that was my approach to this problem. If you had a different way of going about it, or want to just discuss my approach, feel free to reach out to me. You can find my contact information in the details below. See you in the next one.